Welcome back. In this next video, I will continue on with the demonstration of how to prepare a solution in the lab. In our previous video, we discussed how to calculate the required mass of our solid that will be dissolved in solution. In this video, we're going to discuss and demonstrate actually how to measure out that calculated mass. So a few things we'll need first will be an analytical balance, our copper sulfate, a cleaned spatula, and a weigh boat, a cleaned volumetric flask, and a funnel to help transfer our mass to our volumetric flask if needed. In our analytical balance, a few things first to take note of. We want to make sure we're wearing gloves at all times when working with an analytical balance. It'll prevent us from transferring oils in our hands to the balance itself or to the glassware we're working with. We also want to make sure the analytical balance is cleaned of any residual residue that may have been left by a previous user. Alright, next we can physically measure out the mass of copper sulfate needed to prepare the solution. The analytical balances in this lab can measure down to 0.1 milligrams or 0.0001 grams. We want to make sure we record all of our measurements to that final decimal place. Before we put our sample on the analytical balance, we always want to make sure we put a weigh boat or weigh paper there first. We don't want to put this directly onto the balance. So we'll put our weigh boat on the scale. We'll close the door so the airflow doesn't affect the measurement. We want to first tare the balance or zero it before we start measuring out our 4 grams. All right, in the case where you may have accidentally measured out or weighed out too much of your sample, we don't want to actually ever put that sample, that excess sample, back into the original sample container. We want to move it to another weigh boat where it can be disposed of properly. Take it directly out of the weigh boat. Want to close the door so the airflow doesn't affect our final measurement. 3.995657 will be our final measured mass, which is close enough to our calculated mass to move forward with.